Okay, now we're going to look at a cubic. Again, if I really want to, pick points, eventually we want to stop picking points, but where does that equal 0 at -1? A point above that is 0 and a point below that is -2. If you're uncertain how I'm getting that, put it on number line and pick a point below and a point above. -1 in there will give you a 0. A 0 in there, 0 plus 1 is 1, cube it, you get a 1. And -2 plus 1 is -1, cube it, you get a -1. So what you're trying to do, you're trying to figure out where those 3 points are. And those are really the main characteristics of this graph. -1, 0, 0, 1, and keep in mind, anytime you do this, you connect that like a parabola, and -2, -1, you connect that like a negative parabola, and there it is. Right? And what happens if they multiply the y by a negative? Well, it doesn't matter. Where does the inside equal 0? A point above it and a point below it will do. Above that 0 and below that 0. A 0 in there will get me a 2. A 1 in there will get me a 1. And -1 cubed in there, right? Minus a -1 cubed plus 2. That is 1 plus 2. That's a 3. So 0, 2, 1, 1. Wait a minute. It should be above, but do you see the minus? It's going to have an effect. So I start with those and I connect it like a parabola, but it's reflected. And -1, 1, 2, 3. Now, if you're uncertain, if you're not sure how that looks, not a problem, pick more points. By picking those points, I'm giving you what this looked like. But sometimes this thing reflects. So if you're not sure, you went to 0, you picked a point 1 and -1, go to 2 and -2 to see the pattern. Put a 2 in there. 2 cubed is 8. -8 plus 2 is -6. 2, 1, 2, 3, 4, 5, 6. So do you see now? And if you put a -2, -2, that's minus a -2 cubed plus 2. That is a -8. That's 10. So -2, 10, and you could tell it's going to run out back. How about this example? I'm going to figure out where this equals 0. That equals 0 at 3. A point above 3 is 4, and a point below 3 is 2. A 3 in there will make that a 0, times a half, that's 0, plus 2, that's 2. A 4 in there. 4 minus 3 is 1. Cube, that's 1. 1/2 plus 2 is 2.5. If you put a 2 in there, 2 minus 1 is -1 cubed. It's -1. That's -1/2 plus 2. Isn't that 1.5 or 1.5? Now, 3, 1, 2, 3, 1, 2. That's the main point. 4, 1, 2.5. 2, 1, 2, 1.5. There it is. Absolute value, we know how that looked like. What if they gave us an absolute value of x minus 2, x and y? So I'm going to take the inside of the absolute value, set it to be 0, that's at 2, a point above it, 3, and a point below it, a 1. Put a 2 in there. 2 minus 2 is 0. A 3 in there. 3 minus 2 is 1, absolute value of 1 is 1. A 1 in there. 1 minus 2 is -1, and absolute value is a 1. 2, 0, got it. 3, 1, and 1, 1. Again, the main 3 points that you need to sketch a graph of an absolute value. You need to know where does it change. Those points are given right there and right there. I could do better than that. So again, this author, I'm telling you this multiple times, hopefully you're not going to forget. This author will draw the graph this way, indicating that this continues forever. How about this problem? X and Y, well, let's see. Where does the inside equal 0 at negative 3? A point above negative 3, negative 2. A point below negative 3, negative 4. A negative 3 in there will make that a 0 times 1/3, that's 0 minus 1. Very good. Negative 1, negative 2, negative 3, negative 1. So I know where this graph begins. That's this point. A negative 2 in there. Negative 2 plus 3. Negative 2 plus 3 is 1. That is 1/3 minus 1. Isn't that negative 2/3? So, negative 2, negative 2/3. Isn't that less than 1? Time out. Yep, that's right. And probably here. We scale this because the 2/3 are a bit hard to see. Let's go with 1 units each. So negative 1, negative 2. Yeah. There we go. Negative 1, negative 2, negative 3, negative 1 is the first point. Negative 2, negative 2/3 is about right there. And how about negative 4? A negative 4 in there. Negative 4 plus 3 is negative 1. Absolute value of negative 1 is 1. That's also 1/3 minus 1. That's 2/3 negative. So negative 1, negative 2, negative 3, negative 4, negative 2/3. And if you connect this with a straight edge, the parabola is more flat. So I'm trying to see, okay, if this number happened to be a number between 0 and 1, that really flattens the curve. And it seems if this number is bigger than 1, it really stretches. Not flatten, make it more sharp. Or sharper, I don't know if that's a word. So how about this problem? The same deal. Where does this equal 0? A 4. A point above 4 is a 5. And a point below 4 is a 3. Put a 4 in there. That's a 0 times negative 2, 0. That's a 3. 1, 2, 3, oops. 1, 2, 3, 4, 5. 1, 2, 3. 1, 2, 3. You could scale this any way you want as long as you are consistent. I put a 5 in there. 5 minus 4 is 1 times negative 2. That's negative 2 plus 3 is a 1. 1, 2, 3, 4, 5, 1. Do you see what happened? I'm supposed to connect those with a straight edge, but that's not going up. That's coming down. Well, yeah, there's a negative there. What if I put a 3 there? 3 minus 4 is negative 1. Absolute value of negative 1 is 1 times negative 2. Negative 2 plus 3 is 1. 1, 2, 3, 1. And there it is. Yes, this is upside down. That's what a negative does. Hopefully you figured that out when you looked at this. Do you see when you multiplied by a negative that instead of the graph opening up, it opened down? Something I'm going to get in another lecture. And let's get the radicals out of the way. So if I look at a radical, so okay, well, I got to be careful with a radical because what? Of domain. So I look at this, say, wait, what's the domain? X minus 2 must be bigger than or equal to 0. This part. So x has to be bigger than or equal to 2. Every time I do a graph of a radical with an even index, or a rational, or a log, I have to worry about domain. So when I say x and y, well, look at this. If you set this equal to 0, doesn't that give you a 2? A point above, I'm going to go to 3. But a point below is not allowed. So let me see. If I put a 2 in there, I'll get square root of 2 minus 2 is 0. So 2, 0. Very good. A 3 in there. 3 minus 2 is 1. Square root of 1 is 1. 1, 2, 3, 1. now. I know what the shape look like. I want a third point. You don't have to, but let's get a third point. Does it make sense to put a 4? If I put a 4 in there, isn't that the square root of 2? I don't have a calculator. How about 5? Square root 5 minus 2 is 3. What if I put a 6? A 6 in there. 6 minus 4 is... 6 minus 2 is 4. Square root of 4 is a 2. 1, 2, 3, 4, 5, 6, 1, 2. Wouldn't it be wise not to choose those? A smooth curve, there's the graph. So again, we're mimicking this graph. We notice it shifted 2 units to the right when this was a minus. What if it's a plus? Well, what do? Don't you pick where does that equal 0 at -1? A point. Oh, domain. I almost forgot. X plus 1 is bigger than or equal to 0. X is bigger than or equal to -1. So I can only pick values bigger than -1. -1. A point above it is 0. That's very good. Now, can you guess what you're going to put for 3 to make that a perfect squared? If you put a 1, radical 2 is not a good idea. If you put a 2 in there, if you put a 2 in there for x, 2 plus 1 is 3. Radical 3 is not a good idea. But if you put 3, why 3? Because 3 plus 1 is 4. Radical 4 is 2. 2 plus 2 is 4. If you put a 0 in there, 0 plus 1 is 1. Radical 1 is 1 plus 2. That's a 3. And if you put a -1 in there, a -1 in there will make that -1 plus 1, which is 0 plus 2. That's a 2. So -1, 1, 2. Do you notice what happened? When this was a plus, it shifted the graph to the left. And the number that's loose here shifted the graph 2 units up. We'll worry about that in another lecture. 0, 3, 0, 1, 2, 3. And 3, 1, 2, 3, 1, 2, 3, 4. Connect this with a smooth curve. There's your graph. And what about the last problem? That's the messy. Well, messy depending on who you ask, because we know how to do this. We know this minus is going to reflect, right? Something. We've been seeing that. We saw that in x squared, we saw that in x cubed, and we saw that on absolute value. So we can kind of guess, instead of the graph looking like this, probably it's going to look like this. But let's not make any assumptions. We have a good way of doing this, and that is by picking points. Where does this equal 0? At 1. Domain, x minus 1 must be bigger than or equal to 0. X must be bigger than or equal to 1. So 1 is right there. A point above 1, 2, very good. Why is that? Because if I put a 1 in there, a 0 times -2, that's 0, that's a -1. If I put a 2 in there, 2 minus 1 is 1. Square root of 1 is an integer. 1 times -2 is -2, minus 1 is -3. It's unwise to put 3 in there. Why is that? Because 3 minus 1 is 2. Radical 2 we don't want. 4 minus 1 is 3. Radical 4 we don't want. If I put a 5 for x, 5 minus 1 is 4. Radical 4 is 2. -2 times 2 is -4. Minus 1 is -5. So 1, -1 is where this graph begins. That's like this point. 2, okay, I went a bit too far. Try to get it to be halves. So half. 1, -1. 2, -3. And 3, 4, 5, -1, -2, -3, -4, -5. Okay, something's not right. That's not right. 1, -1, 2. Oh yeah, that's right. So remember, the shape is supposed to look like this. With that minus, I'm expecting it to look like this. Alright, and there's your homework on page 235. I want you to do number 1 through 30, all of them, every single one. and I need you to pick 3 points on every single one of those. And 31 through 35 asking about even or odd like we did